everyone, welcome to Firelight, the new era of learning. Today we are discussing about convolutional neural networks. Okay, in deep learning, PNN stands for convolutional neural networks. It is a specialized kind of neural network. Okay, primarily used for image recognition, image classification, or object detection, and also video analysis, medical image analysis, etc. Right. Now comes to the picture. What is CNN? Okay. Before that, we want to discuss what are in it. Okay. So today's topic we're discussing about what are the convolutional neural networks about CNN and how does the convolutional neural networks work and what is the actual building blocks like. Okay. And convolutional neural network and the computer vision. Okay. So let's come to the first topic. What are the convolutional neural networks? So about this, CNN is designed to the automatically and the adaptivity learning spatial hierarchical of the features, right? Through batch propagation, it is especially powerful when dealing with grid-like data, such as images, 2D grids of pixels, right? We also say the YCNN for image, okay? Unlike the traditional neural networks, which treat inputs as a flat vector, CNN. So pursue the spatial relationship between the pixels or computationally efficiently due to the parameter sharing. Okay, reduce the number of parameters compared to the fully connected layers. Okay, so we can see the convolution neural network uses the three-dimensional data for the image classification and the object recognition task. So neural networks are the subset of the machine learning, and they are at a high uh, or at the heart of the deep learning. Okay, and nothing but machine learning. Okay, neural networks is a subset of machine learning. We all know about that, and there are at the heart of the deep learning algorithm. They are compromised, compressed of the nodes layers and containing an input layer, one or more hidden layers, and an output layer. Each node connects to the another layer and has an associated weight and the threshold. If the output of any individual node is above the specified threshold value, that node is activated, sending the data to the next layer, right, of the network. Otherwise, no data is passing along the next layer to network. So while we are primarily focused on the feed-forward networks, we also discussed in a artificial neural network in ANN, feed-forward and feedback. So feed-forward neural networks, in that article, there are various types of neural nets, right? Which are used for different uses, cases, and data types. For example, recurrent neural networks also, which is called as RNN, and are commonly used for natural language process, which is called NLP, and speech recognition, whereas convolutional neural networks, ConvNet or CNN, are more often utilized. Okay, for classification and computer vision task, prior to the CNN, manual time computation features extracting the method were used to identify the objects in images, and however, the convolutional neural networks now provide a more scalable approaches to the image classification and the object recognition tasks, leveraging principles from the linear algebra, specifically matrix multiplications to identify the patterns within an image. That said, that can be computationally demanding, requiring graphical processing like unit GPU. Okay. So in that we can say a typical CNN made with a several layers like input layer, convolutional layer, activation layer, which is called ReLU, and polling layer and fully connected layer, which okay, and large output layer, like the layers were connected image classification, right? So key concepts of the CNN is nothing but the kernels, right? Padding, pulling, and depth. Okay. And what are the applications of CNN? We can say the face recognition, self-driving cars, object detections, medical diagnosis for X-rays and MRIs, and video text classifications. Okay, and the types of we ought to discuss the types of the unpopular CNN architectures like LeanNet 5, first CNN used to digit recognition, and AlexNet, ImageNet winner, and deeper networks, and we call VDGNet, uses screen to pre-filter very deep. RESNet introduces skip connections to avoid the vanishing gradient, and intercept GoogleNet efficiently multi-scale convolution, right? So from the topic of now CNN, we discuss how CNN works. Let us see if we identify any object like it consider like let us take a input has a dog running with ball. So first, the CNN has to work like a human brain. Let us understand how human brain will work. Then we move into the CNN. Little bit better understanding about both. Okay. So when you observe any object, when we observe any object, our retina will scan the object. Okay, and LGN with we means it object lies with fine. Okay, uh, large gain number which can be retina will scan and LGN will be identified to relate the input, which is a layer based and which is for texture to the another reference field. Okay. That's step by step. Like V1 recognizes sound and V2 recognizes the object and V4 recognizes the body. Like each step is recognizing the different parts. Okay. Like if the V1 recognizing the output sounds, okay, the dog sound, and V2 recognizing the her structure, pattern moving, and V4 recognizing the behavior. Like this, each and every part recognize the specific nature of the object and it shapes to the retina. Like that, the information passes. Like CNN also same. So if you're entering any input to the optical and with the convolution, then folding, then for after that each and every step of the pattern will be folded to the multiple layers. Okay, then it divides the proper output. So now it's a little bit tricky and little bit confusing to you. Okay. So overcome this large scale of diagram, I put a simple diagram to understand better way to use. Uh, let us let us first discuss how the convolution network works. Right? We also know that convolution neural network are distributed from other neural networks by their supervised performance with images, speeches, or audio signals inputs. They have the main types of the layers, which are convolution layer, coding layer, fully connected layer, right? And the convolution layer is the first layer of the convolution networks, while convolution layer can be followed by the additional convolution layer or polling layer. The fully connected layer is the final layer, right? With each layer, the CNN increases in its complexity, right? Identifying the greater portions of the image. Earlier the layer focus on the Rather, the layers focus on sample features such as colors and edges. As the time data progressing through the layer of the CNN, it starts to recognize the layer elements or shapes of the object until it finally identifies. Okay. So it's a lot of theory and stuff we read it again. So let's put the side of all this theory and we explain the manual. Okay. That is practically and manually. I will explain to you. It is to better to easily understand you. Okay. So this is a future map called identification of the padding. So if a number grid installed, like it converts into the matrix form, it recognizes into a multiple neural network. So it is too tough to identify the pattern too. Let us take it simple. Okay, let's start with the simple. Okay, convolutional neural network CNN, a future we call it as a future map, also called as activation map. Okay, which is useful, which is mostly used in CNN. Okay, to convert some matrix form. Okay, each convolution layer applies multiple filters small matrices like okay to the input image or previously layer output. Those filters are designed to detect the specific pattern like edges, texture, or more complex shapes. Okay, the result of the each filter is a feature map. It highlights where the patterns appear in the input. Let us see. Here we have a loopy pattern called filter. Here we have value of a 9. Let we recognize vertical of the line and diagonal line. How we take it? First we take the value of 9 here. We take the value of 9 from the 9 where the 9 was drawing in the circle. Right? See the matrix in matrix where the vertical diagonal loopy line were following. There we get 1 1 1 1 1. And all the remaining all matrices blocks or cells or -1 where the triggering 1. So in that we identify the 1 1 1 1 1. So there we form a loopy. First part of the circle we take has a loopy pattern, and other we take has a vertical line, another we take as a diagonal. So the number will trigger. The number will trigger. So we take the lines, how it identifies, it is 9. So first we calculate the matrix here like -1 +1 +1 -1, like we get a some little of amount of 0 -1 minus 0.11 like that. It is a we take the 9 because we take the number 9, so we take the 3 into 3 matrix here. So it divides into, according to the input value, we take the matrices. Okay, it divides like that, it will move it until like that, we get a final output like that's one. So where the one will trigger, there the pattern will identify, right? If the one is get here, it means the loop is here, so we consider as six here, like the picture one. Remaining cell, if we calculating the all like 3 into 3, 3 into 3, 3 into 3 matrix for all of the matrix, all the five. Okay. Now many it's 1, 2, 3, 4, 5, 6, 7. So 7 into 6 okay, fine. 7 into 6, 7 7 into 6, 5 matrix. Okay. So it's considered the where the here we get the one output, right? Here we get the one because the loop will be at right here. So we consider the nine. If we get in machine nine, we recognize the one pattern here. Let us see here. So if the loopy pattern gets one here, if nine, if we number has six, it gives a loopy pattern here because it matrix will be like this. Like if we he get one here, well the carry of multiplication of the both matrices. When we multiply with six, it get here one. Okay, here instead of minus 0.33, we get the one. So we consider it as six. Okay, the machine will consider it. It is a six. It identify the pattern of the six. Okay. Now what will happen if I give eight? If it give 8, it will definitely take the both loops, loop 1 and loop 2. We consider an upper and lower. Both sides we get 1 while calculating the matrices. Okay. Like this, we calculating the matrices, we get the 1, both loops. And what happened if I give two numbers? Definitely takes the one side like the this side will be 1 and this side may be 1. Okay, like that. Okay. It takes one here and one here. One is one, this pattern identify for 9, this pattern identify for 6. And a loop pattern detector like if in nine ones it's like how many patterns like a loopy pattern for one here of one vertical pattern for middle and diagonal pattern for identifier, like the pattern will be identified in number, okay, in feature map. So filters may be identified into feature map. We get a final filter all over the filter. We get like this. We separate the pixels here. Like we separate the pixel. It is a one image. It is a one image. It is a one image. The whole gets a one image like this. Like filters, we get the filters. Then filter from feature map, we get a final image. So instead of image, instead of number, we take an image. Like image identification, right? Image recognition also we can say. From image gun, I have a cola. I have an animal called cola. I want to identify cola's ears, cola's eyes, and cola's nose, right? And hands. How you how did you analyze the data of cola by using CNN? Like eye detector. I have the eye of here, right? One and two eyes. So I recognize both eyes. I use the identify pattern as one. Okay, I use the identify pattern as one. So you identify pattern as one. And I detect in this image we say eye is moving. According to the image we have see here we have the eyes. If the image moving, the patterns also moving. Let us see here. Here see we have a one, two, three, six, five eyes. We identified the one eye for the first cola, so two eyes of the second cola, and two eyes for the last cola. Like that, it identifies the patterns. Okay. From the I, let us divide the CNN. Now come into the main concept. We divide the eyes into two patterns and nose into one pattern, here one, and ears into the different pattern. Then filter into head. We get the one structured pattern, final pattern of the image. Okay. From this, we execute the hands and legs both way. Okay. From ear, nose, sorry, eyes, nose, ears, and hands are legs. Okay, we identify the different patterns here. Leg is here, so we can leg here, and hands off in the tree, climbing on the tree. We can see the pattern of one here. So we take the head one separate network and body a separate. We combination the both network. We use the pattern loop and where the pattern will be triggers. That we use the neural networks here. After that, each and every column, each and every cell takes the information of all the data and passes through the every neural network. Okay, and after enhancing of the every hidden layer of the neural network, it identifies it is the cola in final output. What happened if my image is would I had image like this, and what happened if my image is movements? So now my cola is sleeping. Now see the pattern of the eyes were moved, the nose pattern were moved, the ears were moved, the hands and the legs were moved according to this image, right? The animal, according to if the animal is moving, the pattern also moving. Okay, because in the handling with the pixels, right? So like that head body again this pattern again is identified this color like that. Like that we say here other output like so we have the original image. It's sharpened into 01 into some pixels like an edge detect like and strong edge. It identifies the eyes, nose, lip, and hair, hat, like identifying the structures in the pictures. Okay, to identify easily. Okay. Now, what is ReLU? So ReLU or reactified linear unit. Like it is one of the most widely used activation function, like we call it the most activation function of we can say feature map in convolution neural network CNN. It introduces a non-linearity into a model, which is crucial because most real world data is non-linear. Yes, it is most of the data is because non-linear. So let us take example. Here we have a image of cars. It spreads into multi images, so it identify the multiple images of the patterns. We use ReLU here, and after we do conversation again ReLU again we do the polling of the image. Again, in the case of we use padding also like that we use polling conversation ReLU. After the final output, we get the clarity of output here. Or what is it? It's car, truck, aeroplane, ship, horse. So majority of the CNN detects it is a car. Okay, like the ReLU will be work. So now we comes into the main picture, main concept of the what is the actual building of blocks like. So we have a statement called kernel, stride, padding, polling, and fatten, right? So what is kernel? So kernel is nothing but if you take the 5 into 5 matrix and you should be multiplying with 3 into 3 kernel, here we do like this. If we take 109 360 and 538, it is one shape matrix. In the next matrix, like wait, I will explain in simple terms here. You maybe get easily understanding of the matrices. So like this, I will take the image of that matrix. Okay, I have a matrix all like this. So if I take the first matrix, like here I take red pen here. So first it will be travel like this. First it will be take this matrix here, 109, and here. After that, it converts like that. Okay. First it takes this 3 into 3 matrix into 3 into 3 this kernel matrix 1 into 0 0 into 1 9 into 0 like it converts a matrix like here. So we get the final output as one here, like 56, right? So like this, it gets 51 in first matrix. After that, it moves the second iteration, like directly, it moves the second iteration, like it takes these two, this for these three matrices. It's like these three matrices. After that, it moves for the these three matrices. And next, it moves for the next iteration for these three matrices up to final matrices. Up to the block end, after the ending of the block, it takes the here down matrices here like this. It takes it three these three matrices, and after ending of that two, and it takes this matrix again. Instead of down, it takes this matrix. Like it rotates up to the end. After that, it takes this matrix and this, and final has this matrix. Like this, the kernel will be repeat up to the it fill the final output of the matrix, right? Okay. So this is kernel, right? Okay, now what is stride? In the concept of stride, we have a determination like it moves only a certain part. Okay, okay, let us see. In stride, what will happen? It leaves one column, right? It leaves one. Let's see, size stride padding here S2 F3 P0. So what happened means if we start with 492 and to like this concept, so it leaves one of the column and one of the row, like how it will be show, like I will be show like that, this to also in paint. For the check, I only take this diagram only by removing this all. Okay. For better idea, if we take the first output has the three matrices, in the second output, what will the stride do? Or it doesn't take this line. It doesn't take this line. It doesn't take. Instead of that, it takes the line this from it starts with here. Instead of that line, it leaves one call. It leaves every iteration. It leaves one column. And if you're doing the in column, it leaves one column. If you're doing with in rows, it leaves one row. Like this. If I doing like this, if I complete this iteration, I want to come down, right? I want to come down here, right? I want to come down. Okay. When it's moving with opposite direction, it takes like that. Okay. When it come down, it also leaves this direction. It leaves this cell. Okay. It leaves that cell and it's considered with here. It will convert from here. And after that, when completion of five, it leaves this cell or it leaves like that. It works. Okay. It removes one cell and one column. Like that here. I can say here. If the column is moved from here, so it definitely moves. It remove this cell, like each column and each cell will be, each row will be removed while forwarding the iterations. Okay. So it is nothing but thread. So now comes into the padding. So padding is one of the important ones because we did in padding it gets some multiple objects like what we can say if we get multiple objects like we see here multiple objects like means if we take 0 0 0 like here, so I will show one thing. So instead of padding, what happened if in padding means, so if we take this matrix in padding, so in padding what will happen if I take a start with this number startingly, and I want to end again I want to complete the iterations like this. It get one thing. I start with this. I get duplicate here one time, right? It get duplicate, right? Not duplicate. 1209 063 already repeated themselves. It repeated two times. Now it repeated two times. The six will repeat it two times. Now when I am doing this, when I comes into the second iteration here from here, when I go coming in the second down iterations, so the three will repeat two times. The six will repeat three times, right? The six will repeat three times. The zero also repeated three times like that the number of iterations or the numbers were repeated. So from the instead of that we want to reduce that we take a column called here 0 0, like we take a index based row multiple each row and column we take the zero padding. Okay. So from the instead of we take the zero padding here. So we can see it easily identifies it doesn't get repeated again to again. See if we take 0 0 over there, we take each number only repeated up to a single time or double time. Does not repeat up to three times. Why we get the difficulty in calculation, right? It will be rotate one like 0 0 1 time. Like it easy to understand the to calculate the layers of the matrix, right? While padding. The padding is most useful concept in D plus CNN. Okay. So now let's come to the polling. In polling is nothing but in polling we have max polling and mean polling, right? In max polling is nothing but we have in the we have a matrix of 4 into 4. So max polling, average polling, and we have max polling. We call like we have 1 1 6 in this first cell in this 4 2 into 2 cell. We have max value 6. We consider 6 here. In here 2 4 7 8. We consider max value 8 here. Like that each and every matrix, each and every cell, takes a max value. In average value, it takes one, it takes two, it takes one, and it takes one. Like that, in take average polling. Right, the polling will be decided. Okay. Or like let's come to the final topic of the game of flatten. Flatten is nothing but we said in starting point to recognize, identify the images or input by using conversion, max polling, padding, and stride, we use a final output. It divides the n number of layers into It shrinks the input pixel slow to slow, and it will divide a clear and crystal pixel, and gives the proper output to the user, right? From the input. Okay, it converts the kernel valid for padding. We use max polling as 2 by using calculations. We use 2 into 2 into 8. So we get the 24 into this by minus calculation. Here we get the 3, right? Value of max polling. So like that, we shrinking the values of the pixels, and then we get the proper output here. Okay. So, convolutional neural networks and computer vision. So, convolutional neural networks power image recognition and computer vision tasks. Computer vision is a field of artificial intelligence that enables the computers and the system to derive meaningful information from the image, from the digital image, videos, and other visual inputs. And based on those inputs, it can take action. The ability to provide the recommendations distinguish it from image recognition tasks, some common application of the computer vision today. Okay. So where we use marketing in healthcare and retail and automotive, right? In marketing, we use social media platform, provide suggestions on the who might be in photographer that has been posted on the profile, making it easier to tag friends in photo albums, right? In healthcare, computer vision has been more incorporated into radiology technology, enabling doctors to better identifying the cancerous tumor in the healthcare automatic, and in retail, visual search has been incorporated into some in e-commerce platforms, allowing brands to recommend items that would to complement an existing wardrobe. And automotive is nothing but while with the age of the driverless cars has not quite embargoed, the underlying the technologies has started to make its way into the automobiles, improving driving and passenger safely to the future, such as landline detections. Like the neural networks will be worked. So I hope you guys you'd be understand you'd be understand about the CNN. What is the process? So now let's move to the core topic of code. Just explain a little bit about the coding. Let us take because it's get too late and I was getting the pro issues were installing with TensorFlow. So I take the copy of file of code. So convolutional neural networks. So in the network, we use classifying the small images set of 10 data sets from the TensorFlow keras. So we total 10 classes shows in the CNN classification. So we import TensorFlow, we importing some data sets models, data like cars and images. So we take the data, we test the data. After in 2D image, we translate the data like figure like this figure. We translating the figures like this with this lorry like that. So normalization and training, with testing the data and model sequence layers. We use input shapes. We use the ReLU method here. Activation means nothing but we said future maps. So we use each here, and we load the data of the whole like this. We'll be running. We use pattern image identification of our it is number identification. We just use the data of Matplotlib and TensorFlow. We import the datasets layer models, and we here use the X-train, Y-train, Keras dataset. We test the X shape, we get the values here, and use Math here to show the pattern value of it. And using artificial neural network for classification, we use those datasets. Okay, so this is all about the CNN. I hope you guys you understand it, and thank you.